Let's take a look at the PS2 keyboard on the R32V2020 RISC CPU. All of these inexpensive FPGA cards come with the PS2 connector. It's the purple little connector in the bottom right corner of the picture. For the PS2 keyboard, I've removed Grant's Multicomp PS2 Code. I didn't really like what it did, and replaced it with one by Scott Larson. And that code is pretty good. It performs ASCII to, or PS2 keystroke key codes to ASCII conversion, so it's a nice front end for the keyboard, and it provides really what we need, except not exactly, and I'll explain why. The way the PS2 keyboard code works, VHDL code works, is that you feed it in the PS2 clock and the PS2 data, and it gives out the ASCII code for the character that was pressed, as well as driving this signal active, the ASCII new, to indicate that there's data present. But there is no latching of that new data present, and so it required writing an external wrapper around it to latch the data that's coming in when the key's pressed. Without doing latching, if you just pulled the ASCII new flag, it would be high as long as the key was pressed, so it would continue to read the same character over and over again. So I put a wrapper around the keyboard code which looks for an edge detect. It looks at that data valid coming out of the VHDL code for the keyboard, and edge detects when it becomes active. That is, data valid 1 is not yet true, but data valid is true, so that say that it's the edge of the clock, and then it latches up the data and it sets the status bit to 1. So if you read the status port for the keyboard, it comes back and tells you there's data present, and after you read the keyboard, it clears that status flag so that it really truly can be read, and all read will read a single character. It doesn't keep presenting that same character. What I lost in the process of doing that was the ability to use the keyboard for things like a piano keyboard or a game control, where you want to press the button to move a cursor around the screen, or you want to press a button to simulate what would happen if you press the key on a piano. So I've added that function back in with some address decoding here as well, so that if you read one particular address, it reads the data and the status just like it was with the latching values, but it would also give you back the data and the status in a pulled sort of a way, so that you can press buttons on the keyboard and make it do the function or read the current status of that key. So it can work, and I wrote a little example with a piano keyboard for it, and we can take a look at that. Here's the keys on the keyboard mapped to the piano notes from our previous piano example. As I press and hold the keys on the keyboard, the note lasts for the duration of the press. Each of the different keys produces a different tone. The software interface for this consists of 4 addresses. I took the separate 2 addresses for status and data and put them on the same chip select, so these are all 4 separate addresses for latching the keyboard data, the keyboard status for those 2 latch conditions, and then the pulled data and pulled status. So if you want to read the key as it's pressed and for the duration of the press, you can look at the pulled keyboard status and the pulled keyboard data. But if you want to look at the latched value, look at the latched locations, and it works pretty good. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.